Good afternoon, students. So, welcome back to SBR SSLC online classes. So, in our classes, I already discussing regarding about the carbon and its compounds. So, in that, especially, what's the meaning of vital force theory? Okay. So, what's the meaning of vital force theory, and who proposed that vital force theory, and also who prepared the first organic compound present in the lab? Who proposed or who prepared the first organic compound present in the laboratory. So that is a Frederick Kohler by using sodium sulfate and the potassium cyanide. So whenever we heat both, you will get the urea. Urea is the first organic compound prepared in the laboratory by prepared by Frederick Kohler in 1828. Okay, so this is all regarding about the vital force theory. So already you know that what's meaning of vital force also. The next one is the we'll move to the hydrocarbons. Okay, so already you know that what's meaning of hydrocarbons and the classification of the hydrocarbons also. Okay, so in mainly hydrocarbons can be classified as aliphatic hydrocarbon and the aromatic hydrocarbon. Okay, so in aliphatic hydrocarbon only there are again two types. One is the saturated hydrocarbon and the another one is the unsaturated hydrocarbon. The next one is the aromatic hydrocarbon. So in aromatic hydrocarbon, so these hydrocarbons contain at least one benzene ring, then it is known as the aromatic hydrocarbon. Okay, best example is the benzene, toluene, benzaldehyde, benzoic acid. Already given the example also. So that belongs to the aromatic hydrocarbon. Okay, saturated hydrocarbon means compound containing hydrocarbon containing carbon-carbon single bond, then it is known as the saturated hydrocarbons. And next one is the unsaturated hydrocarbon. So in unsaturated hydrocarbon only, the hydrocarbons containing carbon-carbon double bond and the carbon-carbon triple bond, then it is known as the unsaturated hydrocarbon. Okay, then we made another classification. Hydrocarbons can be classified into again three types. One is the alkanes, next one is the alkenes, next one is the alkynes. Okay, so in that I already explained what's the meaning of alkanes, meaning of alkanes, and the why these alkanes are also called as the paraffins also, and you should know the general formula for the alkanes. Then going to the alkenes. So alkenes are nothing but carbon-carbon double bond. They contain carbon-carbon double bond, and alkenes are also known as the olefins. Okay, so already you know the reason why they are called so. The next one is the alkyne. Okay, alkyne. Okay, alkyne means these are also unsaturated hydrocarbons or the hydrogen unsaturated hydrocarbon compounds. Then they should contain carbon-carbon triple bond in them. The next one is the already you know the electron dot structure for the methane molecule and the ethane. Also electron dot structure for the ethene molecule also, and also electron dot structure for the ethyne molecule also. Okay, so here the general formula for the ethine is CnH2n minus 2. So up to this point, so already covered, and we'll move to the structure of the cyclohexane. Okay, structure of cyclohexane. Okay, formula is C6H2. Okay, first we should have to write 6 carbons first. Here, so here there are 6 carbons here. 1, 2, 3, 4, 5, 6. Okay, so you should have to satisfy the hydrogen. That's it. Okay, so for this one, 1, 2, 3, 4. So valence of the carbon is satisfied. So in similar way, so we should have to write like this. Okay, so this one is the structure of the cyclohexane. Here, the important point is you should have to remember this formula and you should have to know how to write this structure also. Okay, this one is the cyclohexane structure, and another one structure is there benzene. Next one is the benzene. Yeah, C6H6. Structure of the benzene. So molecular formula for the benzene is C6H6. Here, first you should out again write 6 carbons here. And in benzene, there is an alternate double bond is there. That's you should have to remember this one. Okay. So already for the first carbon, 3 bonds are over. Okay. So only it make a covalent bond with one hydrogen. The next one is the already for second carbon also already 3 bonds are over. So I am left with one bond that is with the carbon hydrogen bond and another one hydrogen. So another one hydrogen here and another one hydrogen here and another one hydrogen here. Okay. So here 1, 2, 3, 4, 5, 6. Okay, 6 carbons are there, and you should have to satisfy with this carbon. Okay, already between carbon, first carbon and the second carbon, there is always already double bond is there. And next one is the here for the first carbon and the sixth carbon, already one bond is there, and we can make a single covalent bond with the hydrogen because you should have to satisfy the valence of the carbon. No? So that's why I make a single covalent bond with this hydrogen. Okay, that time this valence of the carbon is satisfied. Similar way, so you should be able to see the 6 carbon atoms here. Okay, second carbon. Second carbon means already with first carbon double covalent bond is present, with the third carbon single covalent bond is present. So that's why I make a single covalent bond with one hydrogen. Okay, this is for all the carbon atoms are same. So this is regarding about the structure of the benzene. Okay, you should have to know the molecular formula and you should also know the how to write the structural formula also. So this is regarding about the structure of the benzene. Okay, benzene can be also written as like this. Okay. Then another way of writing benzene is this one. Okay, you can write benzene as like this also. And so already written cyclohexane, no? Just we can write the cyclohexane as like this. Okay, so here first carbon, second, third, fourth, fifth, sixth, and the so it's understood that there is 2 hydrogen here for the first carbon, for second carbon 2 hydrogen, for third carbon 2 hydrogen, fourth, fifth, sixth. Okay, so this is all regarding about the cyclohexane. This one is the cyclohexane and this one is the benzene. So that is the difference. Here in benzene, alternate double bond is there. Okay. So in cyclohexane there is no double bond. Okay. So for you can write this benzene as like this also. Okay. So this indicates that this you can write like this also. Means what meaning in this one is delocalization of the electrons takes place. Here one circle is there, no? That circle indicates that so electrons can be moved in this ring also. That's the meaning of delocalization of the electrons. Delocalization electrons means mobile electron. They can move. This bond can be moved in the ring also. That's the meaning of delocalization of the electrons. So that is regarding about the structure of the benzene. Next one is the some functional group of carbon compound. The next topic is the some functional group of carbon compounds. So in that, so there is a one word functional group. Okay, so functional group is nothing but an atom, a group of atoms present in a molecule, present in a molecule which largely decides its physical or chemical nature then it is known as the functional group. Okay, functional group may be alcohol is also a functional group. Okay, then next one is the aldehyde is also functional group, and next one is the ketone, next one is the carboxylic acid, and there are so many varieties. Amine is also there, so ester is also there. So these are the functional group of the carbon compound here. So by seeing that organic compound, I can classify the that compound belongs to this category. So that's the meaning of functional group. Okay, an atom or a group of atoms present in a molecule which largely decide its physical and chemical nature. Okay, by seeing only, oh, this carbon compound belongs to the alcohol group. Suppose OH is present, carbon containing OH group as a functional group, then that category belongs to the alcohols. Then suppose carbon compounds containing CHO as a CHO, that is the aldehyde group, then belongs to the aldehyde. Okay, so by seeing this functional group only, we can decide. Okay, this carbon compound belongs to the aldehyde. This carbon compound belongs to the ketone. Suppose it contains C11O means that the functional group is the ketone. So that organic compound belongs to the ketone group. Then another one is the carboxylic acid also. Suppose the functional group present as a COOH group, then that all organic compounds belongs to the carboxylic acids. So this is all regarding about the functional group. Then next one is the heteroatom. There is a one word heteroatom. Okay, heteroatom is nothing but an atom other than a carbon, carbon or the hydrogen, meaning is an organic compound containing other than carbon, then it is known as the heteroatom. So here I can write this one as here. So this one is the pyridine. Name is pyridine. So this one is the one of the heteroatom. Next one is the this one is the furan. Next one is the this one is the thiophene. Okay, so here organic compound containing other than carbon and hydrogen, meaning is organic compound containing nitrogen, oxygen, and the sulfur. Those organic compounds belong to the heteroatoms. That's the meaning. Okay, so see here. Here carbon is also there. Here carbon is also there. Okay, so here carbon is also there. Here also carbon is there. Here also carbon is there. But other than carbon and hydrogen, there is a nitrogen is also present here. Okay, so here oxygen is also present. Here sulfur is also present. Here carbons are there. But even though they contain the sulfur atom and the oxygen atom and the nitrogen atom, those are belongs to the heteroatoms. Okay, that's the meaning of heteroatoms. An atom other than a carbon or hydrogen, they are known as the heteroatoms. Okay, so heteroatoms are nothing but nitrogen, oxygen, and sulfur are the heteroatoms. This is regarding about the heteroatom. The next one. First one is the heteroatom, and next one is the functional group. Then next one is the formula of a functional group. And next one is the examples. First one is the heteroatom, that is the chlorine or bromine. Chlorine or bromine. Next one, this one belongs to the halogens, that is the fluoro, or another one is the bromo. The next one is the, you can write this one as fluoro or bromo. Best example is the CS3Cl or CS3Br. Okay, just I will explain it afterwards. The next one, the oxygen atom is present. Suppose carbon compound containing oxygen atom, then first one is the alcohol. First one is the alcohol. So function group for the alcohol is OH. Then next one is the aldehyde. Aldehyde. Functional group is CHO. Then next one is the ketone. Next one is the ketone. Functional group is C double bond O. Okay. Then next one is the carboxylic acid. Fourth one is the carboxylic acid. Carboxylic acid. Here functional group is COOH. Okay, COOH is the functional group for the carboxylic acid. Okay, so this can be written as, so here I will write one as a CS3OH. Okay, so I will take one as the CS3CHO. Then next one is the CS3COCS3. Then next one is the CS3COOH. Just I am taking this one of the R as a alkyl group. Alkyl group. Okay, so alkyl group may be methyl group or the ethyl group. So here, so in some functional group in carbon compounds only. So I am explaining regarding about the what are the functional group. So different types of the functional group. That is the first one. Suppose your organic compound containing one of the chlorine. Okay, it may contain bromine also. It may contain iodine also. It may contain fluorine also. Okay, it depends depending upon the nature of that compound. So you can take this one as functional group as a halogens. Okay, already you know that halogens, fluorine, chlorine, 17 group elements are also known as the halogens. Then fluorine, bromine, iodine, and the extra time. So only fluorine, bromine, and iodines are belongs to the halogens. Okay, so these formula of the functional group is the Cl and the Br. Suppose iodine is there means minus I. Suppose fluorine is there means minus L. So like that only. These are the functional group. Functional group of the halogen, that is the chlorine, bromine. It may be iodine and it may be fluorine also. And the example I am taken this one as the RCl. Okay, R is nothing but alkyl group. What's meaning of alkyl group means hydrocarbon which differ by one hydrogen, then it is known as the alkyl group. Okay, so already know that methane. Okay, so methane is one of the hydrocarbon. Methane hydrocarbon which is differ by one hydrogen. See here, so this one is differ by one hydrogen, then it is known as the alkyl group. Okay, then so you can take another example, C2H6, that is the ethane. Okay, so that also differ by one proton. That's why I written C2H5 here. Okay, C2H6 is the ethane, so that will be differ by one hydrogen, then it is known as the alkyl group. Very important. Okay, so that's why I have taken the example as the CS3Cl. Okay, just I have written in place one of the R. Okay, that is the alkyl group, RCl. Okay, just I am adding this R with Cl and R with Br. Meaning is I am taken one of the example as the alkyl group. Okay, alkyls are nothing but they will be differ by one hydrogen, then it is known as the alkyl group. Okay, so here CS3Cl. Okay, methyl chloride. Common name is the methyl chloride. And the IUPAC name is the chloromethane. Okay, like that you can name this organic compounds also. And this one the methyl bromide or bromomethane. Okay, so for the halogens, you should have to use the prefixes first. Then afterwards, that's the name of the compound. Then come to the oxygen. So these are belongs to the halogen. For halogens, so you should have to use the prefixes. Okay, and for oxygen, you should have to use the suffixes also for oxygen atom. See here, for alcohol, the functional group of the alcohol is OH. Okay, the next one is the I am taken one of the example as the methyl alcohol. Okay, so ROH, simple ROH. This one is the methyl alcohol. Okay, the next one is the aldehyde. The functional group for the aldehyde is CHO. Okay, then this one is the acetaldehyde. Okay, RCHO means acetaldehyde. The next one is the ketone. Okay, functional group for the ketone is C double bond O. Okay, C double bond O. Then, so this one is the acetone. CS3CO CS3 is the acetone. Okay. The next one is the carboxylic acid. Carboxylic acid. So I can write this as COOH as in another way. This is C double bond O OH. Okay. See here, valence of the carbon should be satisfied also. See, C double bond COOH. Okay, this one is COOH. So this is the carboxylic acid. Functional group is COOH. Then next one. Again, I am taken the example is again one of the alkyl group. So this one is the ethanoic acid or the acetic acid. Okay, so this is all regarding about the functional group. Here in exam, definitely based on this only, definitely they will ask one question. Okay, what is the functional group for the aldehyde means CHO? What is the functional group for the alcohol means OH? Then what is the functional group for the ketone means C double bond O. Then next, what is the functional group for the carboxylic acid is COOH. So this is all regarding about the functional group present in the carbon atom. So this is all regarding. You should have to remember the functional group for the alcohol, functional group for the aldehyde, functional group for the ketone. Then next one is the functional group for the carboxylic acid. Most of the students they will confuse with the functional group in the identifying the functional group present in the uh, aldehyde and the carboxylic acid. Okay, only CHO is there means definitely it's going to be aldehyde. Suppose COOH is there means definitely it's going to be a carboxylic acid. So this is all regarding about the function group present in the carbon atoms. I hope you understood this one. Then next one is the homologous series. This is also very important for your exam. A series of organic compounds. A series of organic compounds. A series of organic compounds. They have a same functional group. They have a same identical characteristic also. Okay, but they will be differ by only CH2 group. Then it is known as the homologous series. Very simple. So homologous series means an organic compound containing same functional group and same physical and chemical identical physical property and the chemical property also, but they will be differ in the molecular formula as a CH2 group. Then it is known as the homologous series. Okay, homologous series is a series of organic compounds which differ by a CH2 group in their molecular formula. Then it is known as the homologous series. So I'll give you one of the example. Definitely you will understand it. So example, one is the methane, and next one is the ethane. This one is the methane. Already know that methane formula is CH4 and ethane formula is C2H6. Okay, just compare these two. Just compare these two. See here. Here two carbons are there, here only one carbon is there, that's why it will be, these two will be differ by one carbon, yes or no? Then next one, so compare the hydrogen atoms here. So 6 hydrogens are there and 4 hydrogens are there. 6 minus 4, 2. So hydrogen will be differ by 2. So then it is known as the CH2 group. Okay. Series of organic compound. These are belongs to the hydrocarbons only. That two alkanes. Okay. So this one is the methane and this one is the ethane. Okay. So these hydrocarbons will be differ by CH2 group. Then these are belongs to the, these are called as the homologous series. Okay. A series of organic compound which differ by a CH2 group, then it is known as the homologous series. Okay. Very very important and very easy also. The next, I will take another example as C2H6, that is the ethane, and next one is the propane. Okay, again compare these two. Here three carbon atoms are there, here only two carbon atoms are there. So here it will differ by one carbon, and 8 minus 6, 2 hydrogens, they will differ. Okay, this ethane and the propanes will differ by CH2 group, and this one is also best example for the homologous series. So homologous series is a series of organic compound, so they will be differ by CH2 group, then it is known as the homologous series. Okay, homologous series always differ by a CH2 group, one carbon and the two hydrogen, then it is known as the homologous series. Okay, I will take another one example. This is also important. So either they will ask this hydrocarbon, that is the alkane, or so another possibility is alcohol. See here, this one is the methyl alcohol, and this one is the ethyl alcohol. This one is the methyl alcohol. CS3OH is the methyl alcohol, and CS3CH2 or C2H5 also, we can call it this one as C2H5OH also, ethyl alcohol. Okay, so series of organic compounds, see this one belongs to the alcohol group, no? So this is also belongs to the alcohol group. Okay, a series of organic compound have a same identical functional group also, and even the same physical and chemical properties also same, so that will be differ by a CH2 group. See here, compare this methyl alcohol and the ethyl alcohol again. See here, one CH3 group is there and another one CH3 group is there, OH is there and OH is there, but CH2 they will differ by CH2 group. Okay, so these will differ by again a CH2 group. That's why it is also best example for the homologous series. Okay, so methyl alcohol and the ethyl alcohol are also best example for the this homologous series. Already you know that the molecular formula for the methyl alcohol is the CH3OH, and for the ethyl alcohol CH3CH2OH. Just compare these two. Okay, so CH3 is present, CH3 is present, OH is present, and OH is present. So here CH2 is not there in the methyl alcohol. That's why these will be different by a CH2 group. So then it is known as the homologous series. Okay, so I'll give another one last example. CH3CH2OH. This one is the ethyl alcohol earlier I said, and next one is the propyl alcohol. This one is the propyl alcohol. See, so compare again these two. CH3 is also there, CH3 are also there. One CH2 group is there and another one CH2 group is there, and OH is there and OH is there. So these will be different by only CH2 group. Okay, so these will be CH2 by only CH2 group. That's why. So these are also belongs to the homologous series. Okay, so this is all regarding about the homologous series. A series of organic compounds which differ by a CH2 group, then it is known as the homologous series. So this is regarding about the homologous series. Very very important. The next one. Nomenclature in carbon compounds. See, So nomenclature of the carbon compounds also we can say that IUPAC nomenclature of the carbon compound. Nomenclature means just naming of the organic compound. That's what meaning is. Okay. Nomenclature of the organic compound means naming of the organic compounds. Okay. Naming of the organic compound means IUPAC nomenclature. IUPAC nomenclature is also known as the International Union of Pure and Applied Chemistry. Then it is known as the IUPAC. Okay. So this one is the standard. It will go with the standardization of the naming of standardization. Okay, that's the meaning of nomenclature. Nomenclature is nothing but naming of the organic compounds. Okay, some certain rules and regulations are there to name the organic compound in chemistry. That's why they are put this IUPAC nomenclature also for your study. Okay, then we should have to know the rules and regulations of these organic compounds. Okay, how to name the organic compounds also. Okay, then next one. First, I will say the rules and regulation of the organic compounds here. We should have to concentrate on the nomenclature of the organic compound. In exam, definitely they will give one of the organic compound. You should have to name with the IUPAC nomenclature. Okay. Then, before going to that one, so I want to just say that there is two words. One is the prefix and the another one is the suffix. Prefix means before phrase, suffix means after phrase. Okay, already you know this one in English also. Then prefix are nothing but an alkyl groups and the halogens are regarded as a substituent to all the side chains. Okay, so this prefix is there, no? This prefix is regarded as a alkyl group also and the halogens also. Both together is known as the prefix. Then next one is the suffix. Okay, suffix is nothing but functional group are the multiple bonds present in a compound, then it is known as the suffix. Suffix is nothing but an organic compound containing the functional group or the multiple bonds, then it is known as the suffix. Okay, in suffix meaning is suppose that organic compound containing any functional group or the carbon-carbon single bond or carbon-carbon double bond or the carbon-carbon triple bond, then that it belongs to the suffix also. Okay, so here while naming the organic compound, you should have to see whether which functional group, which suffix is present. Which suffix is present means so that organic compound containing any functional group or any single bond, any double bond or any triple bond is there, that you should have to say that belongs to the suffix. And the prefix already you know that. So it is of the one of the alkyl group and the halogen also. Okay. So for halogens you should have to use the prefix only. Okay. So this is all regarding about the introduction regarding about the nomenclature of the organic compound. So these words you should have to know. The next one. See, while naming the organic compound, so you should have to remember so minimum 4 points in your mind. First one is the suppose whenever they are given the one organic compound, you should have to see how many number of carbon atoms present in that compound. That is the first and foremost rule and regulation of this IUPAC nomenclature. Okay, so I will repeat it. Whether you should have to see how many number of carbon atoms present in an organic compound. That is the first and foremost point. Okay, see whether the given organic compound containing how many carbon atoms. Suppose they are given as propane. Okay, already you know that in propane 3 carbon atoms are there. Okay, so whether the given organic compound containing how many number of carbon atoms. Suppose 3 carbon atoms are there means it is a propane. Okay, so this one is the okay. Here my point is you should have to see how many number of carbon atoms present in that compound. That is the first point. The next one. Next rules and next rule is the, so whenever they are given the organic compound, you should have to see functional group also. Okay, which functional group is present on that organic compound? That is the functional group. Functional groups. Count the number of carbon atom. That is the first point. And next, whether they given any functional group in it or not, you should have to see. Suppose this one is the propane. Okay, already know this one. The next one, see whether they are given any organic, any functional group or not. Suppose they are given like this. Okay, so here I will write with the. Okay, this one is the second point. So what is the second point? Whether that organic compound containing any functional group or not, you should have to see it. See here. So for first example, this one is the propane. So suppose they are given like this. Okay, see here. This one is the, they are given for the second one, they are given one functional group as a OH. See, so this one as they are given functional group as a OH, and already you know that this is belongs to the, that is the alcohol functional group. Okay, so first point is the, we should have to see the number of carbon, how many number of carbon atoms present. Then next one, you should have to see the which functional group is present. Suppose that this one given means definitely it is also one of the simple saturated hydrocarbon. So you can name this one as the propane. Okay. For suppose they are given means one of the functional group they are given means, suppose CHO is there means definitely it's going to be the aldehyde also. Suppose they are given C double bond O means definitely this organic compound belongs to the ketones. Suppose they are given COOH means definitely this organic compound belongs to the carboxylic acid. So this is all regarding about the, you should also see which functional group is present on that compound. So that's important. Then third one. The next one is the, suppose they are given suffix as a suffix as a first one. Okay, suffix as a first one. Then identify or deleting this E. Okay, they are given a function as a suffix. So you should have to delete this one and add a suffix. Okay, that is very important. So suppose I am taken this one as the example. Okay, so I see 1, 2, 3. 3 carbon atoms with the OH group means definitely it belongs to the alcohol family. Okay, so here suppose they are given this suffix as a suffix. Okay, suffix first means. So I will give the list of the suffix name afterwards. Here, third one is the for suffix. So for alcohol, we should have to use OL. Okay, so this one is the suffix. We should have to use the OL as the secondary suffix for this compound. Okay, so here just delete this E. Okay, just to delete this E, add this secondary suffix. Suppose this one is the alcohol means OL, aldehyde means Al, secondary suffix is Al. Suppose CHO is there means that is the aldehyde Al. The next one is the ketone means ONE. Suppose carboxylic acid means OIC. These are the secondary suffixes. Okay, you should have to use this secondary suffix here. Okay. Suppose functional group as a suffix they are given means you should have to use these secondary suffixes. That is the, suppose alcohol is there means use as a OL. For the aldehyde given means you should have to use Al. Okay. So suppose they are given ketone means you should have to use secondary suffix as ONE. Suppose they are given COOH means you should have to use the OIC. Okay. So here where you should have to use these secondary suffix means just by deleting this last, that is the E, you should have to add this secondary suffix. That's it. Okay. So here propane only. So I will write this one as same PROPAN. Okay. So for For alcohol, secondary suffix is OL. That's why this one is the propanol. This one is the propanol. So this is the third rule and regulation of this IUPAC nomenclature. And next one is the fourth one. Understood? No? Suppose they are given functional group as a suffix, then you should have to use these secondary suffixes. Okay, you should have to use secondary suffix. For alcohol, you should have to use OL. For aldehyde, you should have to use secondary suffix as AL. For ketone, you should have to use secondary suffix as ONE. And for the carboxylic acid, you should have to use secondary suffix as OIC acid. And next one is the 4 point. Suppose your organic compound containing saturated, you should have to use ANE. Okay, only for single bond. Okay, for single bond. Suppose your organic compound containing any unsaturated hydrocarbon means you should have to use ENE. ENE means carbon-carbon double bond. And your organic compound containing carbon-carbon triple bond, that is also unsaturated hydrocarbon. So you should have to use YNE. Okay, carbon-carbon triple bond. Okay, so for this one, so this was a simple saturated hydrocarbon, that is the propane. Between carbon-carbon single covalent bond is present. That's why it is a. You should have to use this suffix as a ANE. Okay, that's why propane. Suppose for this compound only, carbon-carbon double bond is there. Okay, so I'll write this one as already double bond is there and another one double bond is there. So one hydrogen and three hydrogens. This one is the propene. Okay, this one is the propane because between carbon-carbon double covalent bond is there. That's why it is a propene. Propene. Okay, suppose carbon-carbon triple bond is there means carbon-carbon triple bond. Between carbon-carbon triple bond is there means this one is the one hydrogen. Already this one is satisfied. Already this one already satisfied here. Then next one is the Cl. You should have to see the bonds present in the organic compound. Okay, so in that carbon-carbon double bond is present, but here carbon-carbon triple bond is there. Okay, so between first carbon and second carbon triple covalent bond is present. Between second carbon and the third carbon single covalent bond is there. Okay, so that's why this one 1, 2, 3, 3 carbon atoms with the triple bond. That's why it is a propine. Okay, you should have to use this YNE, propine, because between carbon-carbon triple covalent bond is present. So this is all regarding about the nomenclature of the carbon compounds or the IUPAC nomenclature of the carbon compounds. Okay, thank you.